So hi guys, it's me Deepak and let's see what is a neural network. Neural network is a classification algorithm. It performs parallel processing, used image recognition, speech recognition, and they recognize underlying pattern in a given set. But what do you mean by that? So let's start from the beginning and rewind the tapes. So to start with, let's start from the word neuron. So a neuron is basically a nerve cell that carry or undercarry electrical impulses from our brain to body and carry information that tells our body how to react, and the electrical signals are usually from axons to dendrites. The neurons fire when they have enough electrical stimulus and pass the electrical signals to the next neuron. So what does it have to do with the neural network? So when suppose we have a given set of information and we put that information into a neuron, and it have connections to the neuron which can be represented as weights. So when there are enough weights and activations are present, the neuron will fire and give a certain output. Also, each neuron will have a certain bias, and the weights that they are connected with in the starting are random, which will be modified later on. So in activation function, a single neuron will give one out of two outputs, either a plus one or minus one. So we can say that a neuron gives a linearly separable outputs. So it is either below the line or above the line. If it's above the line, it's plus one, and if it's below the line, it's minus one. So you can represent it in the form of a graph. You can use it as a sigmoid graph, a tan hyperbolic graph. So this is basically how the perceptron works. So far we have seen how a single neuron will give a certain output. Now let's see what I mean by a linearly separable outputs. So as you can see on the linearly separable line, that the slope is basically are sum of all the activation values and their weights, and also the rate of bias and its value. So if it's above, or if the neuron fires, it will be above the line, and if the neuron does not fire, if the value does not hit the threshold, a certain threshold, it will be below the line. Now let's see an AND gate. Suppose you have two values a1 and a2, 0.5 and bias 0.9, minus 0.9. So when both are present, the sum will be 1 and minus 0.9, which will be positive 1. So positive bias, so positive activation value. And for other three cases, you will have a negative value. So you can, but you still can separate them with just one line or one neuron. But if you see a XOR gate, you can see that you cannot linearly separate them with just one line or one neuron, because there's no way to separate them. You can add other planes, but that will be in a support vector machine. But here you cannot just do them with one neuron. You need three neurons to separate them. So in these cases, we can see the limitation of using only one neuron, and why we use more than one neuron in practical or real life situation. So I told you earlier that weights are chosen randomly and they are modified later on. So as you can see on the screen, our neural network trying to verify what weight should choose to have a linear separable line. So the connection is chosen randomly, and in perceptron model you increment the weights, or you change the weights in incremental learning format. So you take one weight and change its value to see if it gives you a correct output or not. So you're not gonna achieve this in one try or multiple tries. It takes a long time, or in coding language you call them epochs. So here is an incremental learning format where you take one value, and later we will see a patch increment where you take all the values in a group and change them. It has one limitation although in incremental learning, that the values will not what if the output you get are not linearly separable, because you were taking one neuron here also. So let's talk about how you are gonna change the value of your weights, or how are you gonna upgrade your value. So you have old weight, and how you're gonna change it to new weight. You basically take a learning rate or small positive constant multiplied by the difference between the desired output, the output we want from our input, and multiply it with the value of our inputs, and then you calculate your delta W. So one thing to keep in mind is that delta W will never be zero, but it will be close. So let's see gradient descent or patch level learning. So it's a more general one, and it's used in most of the real life situations. So here we tries to minimize the error, or minimize the squared error. This can be done by drawing a perpendicular line and then drawing a tangent to our error value and getting closer and repeating this process until we get to the um, local or minimum value that we can achieve from this value. Here also the error will never be zero, but it will be close enough that the desired output and the output we get are not that different. So here, as you can see, I've drawn a graph where we have two values, and then we try to draw the error and try to achieve the lower point to get the minimum error. Now let's see an example in TensorFlow. We have Fashion and Mist, which already had a dataset of 70,000 different labeled images and 10 class of different codings. So let's load the dataset first and have 60,000 images for training a model, and testing a model we have 10,000 images. So you can have images in RGB or 3 or grayscale, that is 28:28:1. So let's have our image and put it in our matrix form so we can see it in pixel values, and then feed these pixel values to our not feed, or let's flatten these pixel values in the form of those input as we have seen earlier or we are familiar with using a flatten function in Keras. So as you can see here, it's not like I'm connecting those values, I'm just depicting how you're gonna do this. This flattening this will have an output of 784. Now let's see the function in TensorFlow and how it works. So first you will start by using Keras library. You will use flatten function to make this matrix into a linear data set of 7. Let's suppose it will be a 784 because you're using 28 cross 28 images, and then you will have a hidden layer of neural networks which will be 512, and then you will have an output of 10 because you have 10 clothings. So each input data set will be connected to the neuron in the hidden layer. They will be 512 and the input data will be 784. So the input data set will be connected to each neuron in the hidden layer, and they will fire when they have the sufficient stimulus to give the output. But as you know, we don't get the sufficient output until we have trained this model for a number of times. So we use optimize and loss values to improvise our model and get the desired output that we want. Guys, thanks for watching, and in the next part we will try to cover backpropagation and the calculus regarding this, and also how support vector machine works and how we tackle the problem with non-separable functions or values. And if you like this video, do consider subscribing and click the like button. And as always, thanks for watching.